So in this mini lecture, I'm not going to be using the research from other scientists or people who've been on television claiming to be scientists, because that's a load of crap. It's so boring it makes me want to take out my pacemaker. All these old lectures are full of math and stuff. What's real science should be entertaining. I should know, I went to Oxford. I didn't teach there, I just cleaned the toilets. Anyway, let's move on. Today I'm going to be talking about atoms. Atoms are small, much like the brain size of my former students. Anyway, atoms are small. They make up every single thing in matter. They're mainly made up of three particles: protons, neutrons, and electrons. Electrons are the smallest. They're negatively charged because they're really down on things. I don't know why. Maybe they're just sad. Maybe they just need talking to, you know? That kind of reminds me of one point there was a student who I taught. He was really sad. He was so sad I just kicked him out and I said, "Hey, what are you so sad for?" Anyway, now that that's been said, let's move on. Protons are positively charged. They make up the big brunt of the atom. Don't ask me why, they just are. Then you have neutrons, which people claim don't have any charge, but they actually do, but I'm not going to explain it now. Leave that to people like Richard Feynman or Albert Einstein, not me. See, 'cause I don't have a degree. But you may be asking me, so, sir, how are these atoms held together? Well, they're held together by something called the strong nuclear force. The strong nuclear force acts on the nucleus. The nucleus is the central part of the atom, and it makes up about 99.9% of its mass, because the electron is that small. In fact, if you were to expand an electron out so the nucleus was the size of a tennis ball, the electron would about be the size of a dust particle about 1 kilometer away. I don't know why you want to do that, though. 'Cause that's stupid. Anyway, the strong nuclear force holds it together. It's like gravity except on steroids, because it's much, much stronger than gravity. In fact, it's one of the strongest of the 4 natural forces. However, it only has a very short range. Talking a couple of femtometers, which is small. In fact, speaking of femtometers, I invented the femtometer. Except those people at Oxford kicked me out because apparently you can't invent a femtometer through human experimentation. But anyway, let's move on. So, atoms are small, we've gathered that. But, you may also be asking, well, can we divide them up to be even smaller? Well, yes we can. Protons and neutrons are made of something called quarks. Quarks are even smaller, and they come in 6 varieties: up, down, top, bottom, charm, and strange. Don't ask me why they were named this way. I would have just called them Billy, Bert, Bob, Bill again, John, and Cedric. I just would have. I don't really know why. I don't know what other thing is these days. I just need to keep taking my medicine when I go to bed at night. Either that or I just go have a drink. I don't really know why. It kind of just reminds me that once I went to the cinema with one of my students. I don't remember what we saw, but then he went to the bathroom and he left all his popcorn there. I forgot what I was gonna say. Anyway, these quarks are small, but they can't exist by themselves, because that would be breaking the laws of nature. And according to Richard Feynman in his book QD, he says that quarks cannot exist by themselves, because a quark of every color needs to exist in a state together. That's why you can only get a quark and an antiquark, or a 3-quark pair. Now this may seem very complicated to you if you're under the age of, I don't know, 18. But trust me, when you go to Oxford or somewhere like that, they teach you more of these things. Don't honestly ask me why. Like I said, I didn't teach. But yes, atoms are small. And for more information, if you want a detailed guide, please visit my website, www.pornhub.com, for the latest science news.